Okay, here I want to show you how we can merge two sorted lists in O of n time. So here I've got cards and they're both sets, and I'm thinking of these as my sorted list. Both sets, or both sorted lists are sorted from big to small. So how I can merge them together is I look at the first one in each pile, and whichever one's bigger, I put that in my output stack. Okay? So I can just keep going through each time comparing to see which one is bigger. Compare these two, the 8's bigger, the 7's bigger, the 6's bigger, 5 is bigger, 4 is bigger. And then once I get to the end where there's no more cards left in one of the stacks, I can just take the whole stack and glue it to the end. And that gives me a sorted list. Okay, here we're going to look at MergeSort. And right now what I have is a deck of cards and they're not sorted at all. And I want to do this recursively. That's how MergeSort will do it. And when we're thinking recursively, we're thinking maximally lazy. So I'm thinking, well gosh, what if I just delegate, hey, if I ask 2 other people to sort these, then I know I can combine them in O of n time. But remember, if we're doing this recursively, then when I ask these people to sort it, they're just going to split it in half and ask 2 more people or 2 more methods to sort it for them. And this can keep continuing. So each person who's asked to sort a stack of cards can just split their stack in half and ask someone else to sort that half stack for them. Then once they get that stack back sorted, they can combine them together using that merge algorithm. There's also a natural base case. So say someone asks me to sort a single card, I can just return it to them. And if someone asks me to sort 2 cards, I can split them and ask them to be recursively sorted for me. Okay, they're each just 1 card. So they're gonna hit a base case when I ask someone to sort them for me. And then when I get them back, I can look at them and use my merge algorithm to see that the big one and then the next one. So one step above the base case, I can still just use my regular merge algorithm to put them in order. Okay, I'm gonna have you pause the video and write 3 Racket methods. One is gonna be called merge. It should take 2 lists that are already sorted and combine them into one final sorted list. And you can just assume that the lists only have numbers in them. Next, I'm gonna have you write split. That should take a list of numbers and it can return a list of lists. The first list in that list of lists should be the first half of the list, the input list, and the second list in that list of lists should be the second half of the input list. Another way you can do it is you can just write 2 functions. One is first half and the other is second half. So to actually split up an input list, you could just call those 2 functions to get each half respectively. The last function I'm going to have you write is MergeSort. And you're going to need the merge and this split that you've written before. So pause the video here and try and do all 3 of those. And when you come back, I'll show you some example calls to each of them before I walk through how to code each one. Okay, we're about to write merge. Let's write some test cases first. These can be really helpful for figuring out what some of the basic behavior is going to be. For example, if I call merge with 2 empty lists, that should give me the empty list. And if I give it a list and an empty list, it should just return that list. And that should work regardless of whether the first list is empty or the second list is empty. And we can hopefully see that this is getting me to start to think about some of my base cases. Okay, that probably covers my base cases, but I still want to work with really simple cases. So say the first list has 3 in it and the second list has 4 in it. I expect my output to be 3, 4. Oops. I want to do this biggest to smallest, so it should be 4, 3. I'm not going to add in any test cases where my input lists aren't in the correct order, so I want these to be bigger and then all the way down to smaller. And I'd want one to make sure that if the first thing should come from the first list or the second list, it still works. All right, and I'll throw in another test case. Okay, that's great. And now once I write merge, those test cases should all pass. Right now they shouldn't pass. And you can see I got a bunch of failures. Okay, so pause it here and try and write merge. Okay, so now I'll try and write merge. And I'll call my lists A and B. I think I'm going to have more than 2 cases, so I'll get myself set up with a cond. I think it's helpful to give myself that structure because I think it's easy to get lost in the syntax. Okay, like I saw in the cards example, if one of my lists is empty, I just return the other list. So if A is empty, I can return B, and if B is empty, I can return A. Okay, now to the actual comparison. I'm assuming that A and B are both sorted lists and they only contain numbers. So I want to compare the first of A and the first of B. So let's see if the first of A is greater than the first of B. Okay, so that'll be one case. And let's do the other one too, where the first of A is less than the first of B. So if my lists are sorted from big to small, if the first of A is bigger than the first of B, I want to keep the first of A. So I'm going to cons the first of A onto my resulting list. So here I need to recursively call merge. That'll give me a list that I cons first of A onto. And now I've already handled the first of A, so I just need the rest of A, and B is unchanged. Cool. If instead if instead the first of B is bigger, then I want to cons on the first of B onto the merge. And then A won't change, but I'll take the rest of B. Okay, there's one case we haven't handled where the first of A and the first of B are equal. I could actually say if the first of A is greater than or equal to the first of B, then I'll take the first of A, because it doesn't really matter which one I pull it from. And since I end up here without an else case, I actually can delete this predicate and just turn that into my else. Okay, and then we can put it all together to make sure that we pass all of our test cases that we wrote before we wrote the code. And it looks good. Okay, let's write some test cases for these functions first half and second half. Okay, so if you call first half on an empty list or second half on an empty list, you should get an empty list back. What should it do if there's just a single element in there? Well, first half should have it and the second half shouldn't have it. What if there are 2 elements? The first half should have the 4 here, and then the second half should have the 3. Let's look at the 3 element case. This can be really helpful for thinking through what our code should do. So say there's 3 elements. We can see in that 1 element case that we decided if there's an odd number, that we would get the extra one in the first half. I'm actually going to change that behavior. I think it might be easier for us to have the second half have more elements in that case where there's an odd number of elements. So in the case where we call first half on 5, 4, 3, I want that to just have the first number, and then the second half will have that extra one. Okay, I think this is enough to try and write that code. And right now, all of these, essentially, except for those base cases where we should be returning the empty list, all fail. And oh, look at that. I got an extra line there, an extra copy of that base case. Okay, we're going to write functions first half and second half. I'm going to do this with a helper function. So I'll say first half helper, and I'm going to pass it the list. And then I want to pass it a number, and the number is the number of elements I expect in the first half. So I can call length on L, that's the total number of numbers. And then I can take the quotient of that and 2, and that's how many numbers I expect in the first half. Now let's try and write that helper function. So it takes in a list, and then it takes in a number. If that number is equal to 0, that must mean I don't need to add any other elements and I can return an empty list. Otherwise, what I can do is I can cons the first of that list onto the recursive call with the rest of that list, and then I'm going to subtract 1 from that number. Okay, the second half can look really similar. I'll call second half helper. I'll pass it the list, and I'll pass it that number as well. Except now this will be the number of elements to get rid of. So let's write that helper function. It takes in an L and a number. If that number is equal to 0, then actually we're just going to return the rest of the list. That means we don't have any more elements to get rid of. And otherwise, we're going to make a recursive call with the rest of the list and one smaller number. And hopefully you found this to be good practice for writing recursive functions using Racket. Okay, now let's write some test cases for MergeSort. If I try and sort an empty list, I should just get back an empty list. If I have a single element in it, I should just get back that single element. If I have 2 elements in it that are out of order, I should get them back in order. And again, we're going big to small here. All right, and I'll throw in another case. And the correct answer here should be 10, 8, 5, 4, 3, 1. Okay, looking at MergeSort, let's get started on that. Again, I think I'm going to have multiple cases, so I'll get my con set up. Okay, so if my list is empty, I just want to return that list. And actually, if the rest of my list is empty, I take the rest and then check if that's empty, and that I'm also going to return the list. And remember, we want to try and avoid checking length in a base case because length is an O of n operation where n is the length of the list. Okay, so if I get to this last part, this else, that means that I have at least 2 elements. And here I want to call MergeSort on the first half of my list, and I want to call MergeSort on the second half of my list. Each one of those is going to return a sorted list, and then I can merge those together. A really common question is like, wait a second, where is it actually getting sorted? And I think merge is really doing the heavy lift because it's taking those 2 sorted lists, whether they're 1 element each or 1,000 element each, and then combining them together in the correct order. Let's wrap up with a review of MergeSort. So we can merge 2 sorted lists in O of n time, where n is the sum of the length of the 2 lists. And then we can also recursively sort lists. If we have 1 or 0 elements, it's just already sorted. If you have more elements, we can split it into 2 lists and recursively sort those. And then when you get those 2 sorted lists back, you can merge them. So here's another visualization of that merge algorithm. And again, this happens in O of n time, where n is the sum of the length of the 2 lists. And you can imagine that step 1 is that we call MergeSort on each half. So we split it and we call MergeSort. So those arrows we call MergeSort on each half of the input. And then once we hit the base case, we can merge those 2 results back together because those 2 results are going to be sorted lists. So there, that arrow means that we can merge the results of our call to MergeSort. So big picture, we see we split it, then we got to the base case, and then we backtracked through the recursive calls. And you can imagine it sort of sequentially too, where we went through and called MergeSort on each, and then it backtracked through. Just like factorial backtracks through, except this one's more complicated because we divided it into 2 and made 2 recursive calls. And I just want to draw your attention, all the examples there had a power of 2 elements, but it doesn't necessarily have to be sorting a power of 2 element list. So here's an example where you end up with odd numbers of elements. And similarly, we would still merge them all back together. Okay, so just to dispel the misconception that it has to be a power of 2 number of elements, it works no matter what. And again, I think this perspective of a single call to MergeSort is super important. So we call MergeSort on each half, and then we merge the 2 resulting lists back together. So from within a single call to MergeSort, that's what we see. 2 calls to MergeSort and then a call to merge.